Good afternoon, all.
Afternoon, sir.
Hi, Mario. Welcome. I was looking forward to seeing you from Friday, but you didn't want to spend your Friday afternoon with the locals, so welcome, sir. All right. The rest of you, I have a warm-up question for you. Example number 5. We need to see if we can get through this for the piecewise function, and then I'm going to be starting our differentiation from first principles. So I'm hoping you are hearing me. So it is that we can get some stuff done up. Amanda and Tristan, I will need to have a conversation with you. Can you start for me, please? Thank you.
Good evening.
I asked them, boy, there's a warm-up question here. Question number 5, example number 5. We'll look for you to make an attempt of it for me, please, and thanks. How far the rest of you are?
Okay, sir. Sir, I have a question.
Mm-hmm.
For EducoSoft, if I have done a quiz and the grade is not satisfactory, could you reopen it?
If you ask me nicely, I will think about it.
Okay. All right, sir.
No problem, my love.
Hmm.
How far the rest of you are with the question, please?
Nowhere as yet, sir. Just give me like 30 a joke. Then we were like 5 more minutes.
5 more minutes? All right, no problem, Papa. The rest of you,
Finish now, sir.
Thanks, Shamari. Anybody else has completed the work?
Almost.
Almost, all right. Simon, how far are you?
Sir, I just finished.
Okay, good job. Tristan, how far are you?
Finish, sir.
So, the one on the done on the sit down there, I don't understand. Say something.
No, sir, we just write the last answer while ago. We just
No, but
finish.
you finished long time, man. It's all right. That's how you're going, man. All right, good job. Amanda, how far are you? Amanda, how far are you?
Sir, I just left work, so I'm on my way going home.
Okay.
Finish.
Adrian? Aston, you finished now?
Yes, sir.
Good job. Mario, I know I gave you specific instruction through Miss Campbell. Did you make an attempt of this?
What instruction, sir?
You got connected to the YouTube channel, right?
Yes, sir. I saw
Did
this.
you watch the videos?
No, sir, I didn't get a chance to.
Well, you didn't follow my instructions, sir, so you are going to be fully lost. All right. Let's see how best we can go through this now. Hold on, please.
Sir,
Yes, afternoon.
sir, as I said that, what kind of message that I saw in my email coming from EducaSoft?
Because you guys are not doing the assignment on Educasoft, I sent a message to those persons who, well, to the class. Only one person started something, and that was Shamari.
No, sir, that's not true.
All right, then. At the
That's
time
not
when I
true,
sent,
sir. Check again.
at the
Because when I saw
time,
it, I'm like, okay, then.
at the time when I sent that message, Shamari was the only person that did something. I can check now to see if anybody else has done anything. But at the time when I sent that message, oh, maybe you did the practice and not the actual quiz. So maybe you
Maybe.
did it.
Where,
Yeah.
sir? Edica, sir?
Maybe.
Yes, sir.
No, sir, me start to.
No, well, if you do the practice, I won't see the practice on my screen because the practice is just for your personal development before you move into the homework and the quiz. So
All
maybe you
right,
have
sir, me
started
complete unit one. Me complete all of unit one.
already. Let me not calling you a liar, but I just need to check because remember, we don't have much time. We are going through, remember, we're doing calculus 1 and calculus 2 in this semester. So we need to get the ball going. What am I looking for? Educasoft. So we have to keep the ball going. I'm looking at calculus 1. Is everybody connected to Educasoft now? Mario, you need to Astonil. Oh yeah, you're there, you're there, you're there, you're there. Tristan, you're not there. Mario, can you send me your WhatsApp rubbishness? Send me your email in the WhatsApp group, please. No, so I can get you connected. Okay, now I'm seeing movements. So I'm seeing Simon, good job. I'm seeing Shamari, you need to go back and finish up that one there. Adrian, I've seen Adrian done something. Yes, Aston, I see you've started some work. Good job. Good job. And the question that you asked me at the top of the class, Aston, I've granted it, so you can now go back and look at.
Thank
Uh,
you, much appreciated.
No problem. And Simon, the same thing for you too. But yes, guys, remember, we are doing a block scheduling session. We cannot wait until the end of the semester, which is sometime the end of next month. We have a couple more weeks left for you to start working on your EduCasoft pieces. We must start now. We must start now. So those of you who are yet to begin, please don't tarry. You don't have, it's not a whole lot of assessments on it. I'm seeing 3 and 3, 6 and 3, 9 and 3, 12. We can complete those assessments. Congratulations for those who have started. Big up on yourself. All right, so that is that. Oh, let me go ahead and just add a few more students. Yes, thanks. Mario, I need your school email, please. Or you don't have it just yet? All right, so what I'm going to do, I'm going to use this email for now so that at least you can get connected. But as soon as you get it, you need to change over the email address, please. Understood?
Yes, sir.
So you've been added. I'm seeing 10 of you here. Let me just go back to. All right, so there are a few students who are yet to log on to start doing anything. All right. I really did say that was in a name and shame, but I'm a little encouraged that more of you actually started doing the assessment. All right, so with that said, am I still sharing? Yeah. What am I sharing? Am I sharing EduCasoft or
Still sharing the exercise.
is it exercise? Okay. All right. All right. So Is P continuous at x equal 1? That was a
Sir,
question.
ask the question again, please.
Is P continuous at x equals 1?
Yes, it is.
Is it continuous at x equals 2?
Yes, sir.
Everybody agrees that it's continuous both places? Simon, Shamari, Adrian?
Yes, sir.
So I agree that it's continuous both places. Now, so remember, the numerator to the left of 1 is x squared minus 1. Now, you remember you'd have gotten the indeterminate form, or you get 0 over 0. Same thing. You'll get the, as I say here, can you see the indeterminate form showing up? So you'll get 0 over 0. So it means that we need to do something. We need to do either a simplification, a rationalization, or a factorization. And then now we recognize that the numerator is a difference of squares. The numerator is a difference of squares. X squared minus 1 is the same thing as x plus 1 times x minus 1. When I did that, I then recognized that I was able to cancel my x minus 1 and then left with x plus 1. Having canceled this, I'm then going to substitute x equals 1 into the function. 1 plus 1 is equal to 2. Similarly, I'm going to look to the right of 1. When I look to the right of 1, so Mario, I'm looking at it in the, and you need to go through those videos, Mario. Go through those videos, and then we need to have a conversation. So I'm using the intuitive approach here, where I'm investigating what is happening to the left and to the right of 1. This is x less than 1. When it is less than, it is going to be to the left. Think of a number line. A value less than 1 is a value that is moving to the left on the number line. So therefore, the function that deals with to the left of 1 is going to be my x squared minus 1 over x plus 1. I just evaluated that and got 2. Now I'm looking to the right of the function. To the right of the function, the equation that deals with to the right of the function is going to be 5x minus 3. How do you know that, sir? Because the inequality tells me. The inequality says this is x is greater than or equals to 1. Greater than, it means that it's moving to the right of the function. Moving to the right of the function. So when I move to the right of the function, what is going to happen now is anywhere in the function I see x, I'm going to substitute positive 1. See it here? 5 times positive 1, which is what I have here, minus 3, I'm going to get 2. Now, since the limit from the left of x squared minus 1 over x minus 1 is equal to the limit from the right of 5x minus 3, then p of x is continuous at x equals 1. The function is going to be continuous. They are of a good behavior. It's continuous at x equals 1. In a similar fashion, having investigated what happens at x equal 1, I'm now going to investigate what happens at x equal 2. When I investigate what happens at x equals 2, to the left of x equals 2, look at the inequality. This inequality says x is less than 2. X is less than 2. Now the function that is less than 2, it means that I'm going to the left. So I'm going to say the limit as x tends to 2 to the left. See it here? 2 to the left. The superscript means left. The superscript minus means left. The superscript plus means right. So I'm moving to the left. I'm going to go back to my 5x minus 3. Anywhere in the function I see x, I substitute 2. 5 times 2 is 10, and 10 minus 3 is going to give me 7. And the function that moves to the right now is going to be 2x plus 3. Or you know that, sir? Because it says x is greater than or equal to 2. So it means that once it's greater than, I'm going to the right. Once it is greater than, I'm going to the right. All right? So it's going to be the limit as x tends to 2, superscript plus of 2x plus 3. This 2 superscript plus is telling me that I'm going to the right. Anywhere in that function, now I see x, I'm going to substitute 2. So 2 times 2 is 4 plus 3 is 7. And similarly, since they both are going to the same limit, the function is of a good behavior, and they're equals, so it is continuous also at x equals 2. Outside of Mario, is there anyone in the class who is not seeing what is happening here? Okay. I'm taking that as I'm seeing it, sir. Simon, you got those, you got those things, right? Simon, you got the 2 and the 7?
Yes, sir.
Good job, Papa. All right, now, without giving you any further instructions, all I'm going to read for you is a question, and I'm going to ask you to make an attempt of this question. Yes, you may get stuck at some point in time. I'm not even concerned about you being stuck. I'm concerned about how far you can get to the question on your own, and then I'll take it up from there. The question says, the past paper question, December 2017. It says a function f is defined as follows, where f of x is equal to 2x squared minus 4x plus 2, where x is less than -1. And you also have ax plus b, where x is greater than -1 but less than 1. And you have 5x minus 7, no, plus 7, where x is greater than 1. Our aim is to determine the values of x, no, the values of a and b, such that f is continuous over the interval -infinity to +infinity. What am I saying? I'm asking you to find the values of a that will make this function f of x continuous over all values of x. You just did a question a while ago where the function was continuous. This question is exactly the same as this question, except that I have not given you the value of a and b. You are going to now find the value of a and b. You know what it takes for the function to be continuous. I want you to go far you can get to the question. I'm going to give you 5 minutes to look at it and make an attempt, and then I'll come back to you. Start from it, please. I want all of you to give an attempt. All right?
Sir. Sure.
How we stay, how we feel.
Sir, can you work through it?
I will.
Hmm?
I will, but did you give an attempt to the question?
I did.
Okay, anybody else gave an attempt to the question?
Yes, sir.
Did you get an answer for A and B, Simon?
No, sir.
Shamari, how you stay?
I'm still working, sir, so I would have liked some more time.
All right. I'm gonna give you, it's now 6:05. I'm gonna give you 2 more minutes to look through. I'm gonna do the question. But for those of you who are asking for my assistance, I have no problem. Just look through the question once more for me, please, while I give Shamara some time. The rest of you, you need to give an attempt, please. Two more minutes. Or we know. Or if I reach out to Shamari.
feel like I'm stuck now, sir. So you can
All right,
go on.
no problem, no problem. So I didn't expect you all to get it, but I just wanted you to get very close to it. Now, tell me, what do you understand the question is asking? Hmm?
To find the 2 points at which x are which x is continuous.
Right. So when I do the first piece, so let me just reduce this a little so that I can get a little bit more on it. All right. So I need to determine the values for which when I get those values of a and b, and there's only one value of a and one value of b, that will make this function continuous at all points. All right. So I have 2x squared minus 4x plus 2, and I'm going to the left of -1. So I'm going to have the limit as x tends to -1 to the left of this function. Anywhere in the function I see x, I substitute 1. I need to know where this function is going so that this function can go the same way. Remember, in order for this thing to be continuous, wherever this function is going, this function must go the same place. If not, the function is not continuous. True or false?
True.
So I'm going to substitute anywhere in the function I see x, I'm going to substitute -1. So it's 2 times -1 squared minus 4 times -1 plus 2. When I square -1, I'm going to get +1. So 2 times +1 is +2. And -4 times -1 is going to be a +4. So +2 plus +4 is going to be +6. +6 plus 2 is +8. All right. So I'm going to have +8. When I go to the right of -1, see there, x is greater than or equal to -1. When I go to the right of -1, I'm going to say the limit as x tends to -1 to the right of this function x, ax plus b. The value of x, I'm going to substitute it to be -1. So that's why I have a, open bracket, -1 plus b, and that is going to give me -8 plus b. It must be equals to 8. So how you know that? Because if the function is going to be continuous, when I go from the left and I go from the right, both must go to the same value. Tell me if you agree with that.
Agree.
They must go to the same value. So I'm going to put on that equation. I finish with x equal -1 for now. Then what I'm going to do, I'm going to do the same thing. This is exactly what it is that we're doing. All we're doing now is with unknowns. In this case, what I'm going to start off with is what is happening to the right first before I go to the left. Because whatsoever this one is equals to, this one must be equals to it as well. So I'm going to find the limit as x tends to the right of 1. So how is to the right? X is greater than or equals to 1. Once it is greater than, it's going to the right. So I'm going to say 5x plus 7. Anywhere in the function I see x, I'm going to substitute 1. 5 times 1 is 5, plus 7 is equals to 12. So I know that to the right of 1, it's going to 12. Let me go back now to the left of 1. What you know is to the left of 1, sir? X is less than 1. So to the left of 1 is the limit as x tends to 1 to the minus. It's going to be ax minus ax plus b. The value of x is going to be 1. We're substituting the value of x to be 1, similar to what it is that we did up here. A times 1 is a, plus b is a plus b. It must also equals to 12. But sir, we never work out intermediate. You are putting it equals to 12 because it says determine the values of a and b such that f is continuous over this interval, this wide range of interval. You got from -infinity to +infinity means that it's going to be continuous over every single value of x. That's what -infinity to +infinity is saying.
Repeat that, please, sir.
And I'm saying to you, -infinity to +infinity is telling you that it is the value, the function f is going to be continuous over that range. So every value of x you can find, the function is going to be continuous. So whenever you see -infinity to +infinity, It's either the value is a negatively large value or a negatively small value. Well, a negative value or a positive value. So negative infinity is at negatively large value. Positive infinity is at positively large value. All right. So now you're going to end up with two equations with two unknowns, minus a plus b equals 8, and a plus b equals 12. We're going to solve those equations simultaneously. See them here? Minus a plus b equals 8, and a plus b equals 12. You're solving those equations simultaneously. Mari. We're going to be using the elimination method. So if I add both equations together, minus a plus a cancels out. Tell me if you see that.
Go again with that, sir.
I'm adding both equations, equation 1 and equation 2. Minus a plus a right here. When I add the two equations, minus a plus a equals 0. Do you agree?
Yes, sir.
The rest of you.
Yes, sir.
Tristan, do you agree?
Yes, sir.
Now go and talk to me in the class here, Papa. Real talk. So I'm going to solve it simultaneously. So if I add these two equations, minus a plus a is 0, but b plus b is going to give me 2b. And a plus 12 is equal to 20. And a plus 12 is equal to 20. So I said using the elimination method, so let us add both equations together. Please note that we have to further simplify the equation. B plus b is 2b. A plus 12 is 20. So now, in order to determine the value of b, we're going to divide both sides by 2 so that I can have b standalone. So 20 divided by 2 is going to be equal to 10. So that's the value of b. B must be equal to 10. I now need to find the value of a. Pretty simple. I substitute the value of a in either of the two equations, either equation 1 or equation 2. I've decided to put it in equation 2. And remember, equation 2 is a plus b equals 12. So anywhere in equation 2, I see a, I see b, I'm going to put 10. So it's going to be a plus 10 equals 12. And then I'm going to subtract 10 from both sides. So I'm going to left with a on this side alone. So it's going to be a equals 12 minus 10, and a is equals to 2. So the value of a is 2, and the value of b is going to be 10. And that ends the question. Are there any questions?
Sir, what if it was A and A?
What it was what? A and A for what?
So where we add both equations, right?
Mm-hmm.
You have minus A, you have a positive A. What if both of them were positive, or if both of them were negative, as the same with the B?
What would you have done? Anybody can tell me what operation I would have done right there in order to eliminate it? Hmm?
I'm not sure, sir.
If I have $10 and you ask me for $10 and I give you how much, what do I have left?
Yeah.
So I'm trying to eliminate. What it is that I'm trying to eliminate would have been my A's. But I recognize that one sign is positive and the other sign is negative. So because the signs are different here, I can go ahead and add. But if the signs were the same, if I had positive A and minus A, sorry, if I had two positive A's, I would have had to subtract one of the equations from the other so that I can have A minus A, which is equal to 0. So because the signs are different here, I went ahead and add. But if the signs were the same, as in the case of B, I would have had to do a subtraction.
So then it would be 12 minus 8.
Very good.
Okay, so
It will be 12 minus 8, which is 4. But, all right. Let me show you something. I'm going to write something and show you because I want to make sure you get it. Give me half a second. Let me just cover the thing. Minus A plus B is equals to 8. That's my equation 1. And A plus B is equals to 12. That's my equation 2. If I decide to subtract, I can say, for example, subtract equation 1 from 2. So I'm going to say A minus A. This is A minus a negative A. And then, of course, B minus B is equal to 0. So we have plus 0 is equal to 12 minus 8. A minus minus A is going to be A plus A. And that will be equal to 12 minus 8. And A minus A plus A is going to be equal to 2A. And 12 minus 8 is going to be equal to 4. And divide both sides by 2. A is going to be equal to 2. Which is the same value here of A to be equal to 2. Then I'm going to put A equals 2 into, say, equation 1 this time. Anywhere in equation 1, I see X. Sorry, I see A. I'm going to put in 2. So this is going to be.
sir, hold on.
Mhm.
I don't think you understood what I was asking. So equation 1, we have minus A plus B.
Mhm.
What I'm asking is, what if the A was a positive A for both equation and a positive B for both equations, it would still be a case where you would subtract?
Yes, ma'am.
Okay.
Mhm. Once the signs are the same, you are going to subtract. If the signs are different, you will add. Fair enough?
Fair enough.
Good job. So that's A plus B is equal to 8. So this number becomes -2 plus B is equal to 8. I want B alone to be on one side, so I'm going to say 8. If this is a -2, it then becomes a +2. So B is equal to 10. And the value of B here is 10. So it doesn't matter which way I do it, I'm going to end up getting the same answer. The take-home message, though, is if the signs are the same, you are going to subtract. If the signs are different, you are going to add up. I want to take out this for me. Whoa. Can you see this?
Maybe you need to zoom out back to full screen. Yeah.
All right, so take it off for me, please, because I have one for you. I have one for you to do for me. And as you write, is Shamari back? I know he dropped off.
Yes, sir, I'm back.
Okay, good. Astemil, you know Talia Astemil? You have a number for her?
I think her number is in my phone somewhere.
You said you finish write off this stuff? I'm gonna ask you to call her for me until I say to come to class. Please.
Okay.
Thank you, my love. All right, take it off for me. When you want me to scroll up, I will do that. So hurry up, guys, so that they can all be there. I want you to have it in your books because I'm gonna give you another question. I do expect a question like this on the exam. This is one of those questions that is a must-have. And I'm telling you, the question sometimes comes 7 marks, 8 marks, 9 marks, 10 marks, right? So if you get a 10 marker for this, that's a whole heap of marks. All right, so focus on trying to understand this one, please. Mario, how you feel with my explanation for this question?
Sir, I'm catching on, man. I'm catching on, sir.
Good job. All right, start writing off for me, please.
Sir,
Yes, dear.
Talia says she's at work and she's busy at the moment. She's
Oh,
not able to.
all right. Thank you for that information.
Okay.
Mhm.
Sir, how much you said it's worth?
Sometimes 10 marks, sometimes more. For your mid-semester, Adrian, I think one of these is on it, the same one with the unknown. So if you can maximize your scores on the mid-semester, guys, it sets you up nicely in passing the course.
Sir, are you set them in semester?
Not only the mid-semester, also the final exam. So I have
Alright,
to set.
but is
No,
is
no,
you
no,
set
no,
them
no.
in semester, right?
All right, so hold on. No, let me clarify. So I set both mid-semester and the final exam. However, my mid-semester and final exam will go up to the CCCJ because there are other lecturers within the CCCJ that set their exams as well. And what they do is they select questions. So I can't tell you that my paper is coming or the other paper is coming, but yes. I'll have to wait until the final. So, but yeah, I do have your mid-semester. So it may very well be my questions that come. It may very well be another question from another colleague.
Okay, sir.
But Adrian, if this makes you feel any better, if it is my paper for the mid-semester, you should be fine. Because you're seeing these questions that I am writing. So you're supposed to know how it is that I write. So you should be able to answer these questions. But I'm saying to you,
Okay,
students,
sir.
yeah, man,
Now you know what I'm asking.
I know. So remember, I went to school too, so I know exactly what you all students want to find out. But guess what, though? Um, if you follow my lead, when I give you the mid-semester, you all can pass the mid-semester. But remember, we're trying to maximize on the mid-semester, which I think I'm rushing you guys to complete the EducaSoft pieces. Last time around, I gave the mid-semester way after the middle of the semester because I was waiting for people to catch up and do the stuff. This time I don't have the time because we're in a fast track, not really fast track, but we're in a block scheduling. So I can't wait until March to get the mid-semester. March, we're in calculus 2. We're into calculus 2 come March. So we have to do our stuff because come next week, God's willing, maybe by Wednesday or Fridays, when we're going to get our mid-semester exam, I have enough information now to set a mid-semester and give you.
Sir, Wednesday or Friday this week?
Me say next week.
Okay. Another
Yeah, man.
question. Unit 1 and 2, right?
Yes, sir. All of 1 and 2. And I'm finishing off Unit 2 tonight. If I don't get a chance to, well, I may not finish off the topic for Unit 2 tonight, but I'll definitely start the last topic in Unit 2 tonight.
All right, sir. My final question, coming on all of your class. For EducaSoft, I see we have about 6 units on it, right? We can proceed to completing the 6 units without having to wait on the class?
Oh, that's what I expect you guys to do. I don't want you to just go and do the assessments like that, I want you to read through your
Practice
tutorial.
first.
Right, do the practice, read through your tutorial, get the understanding, do your practice, and then do the actual homework and then the quiz. Yes, man. Work ahead of me. So when you come to class, Shamari used to do it, but Shamari stopped. Him used to watch the
Oh,
recording and work ahead of me, but him stopped. I don't know what happened to him, but him just stopped, bro. But yeah, man, work ahead of him, man. That's why I put all the work on You don't finish right up that yet? I have another question, you know. Can I scroll up?
Yes, sir.
Scroll up, please. Thank you. Finish, sir.
All right, there goes another one. Same idea, but this one is somewhat easier. A question like this won't carry as many marks as the one that we just did, because well, you have two sets of constants there. All right, but give this one a try for me, please. I want you to look at it, look at what you would have done for the first one, and let us see how best you can do this one. Thank you. What is the limit of a constant?
Constant.
Very good. How we stay, how we stay, how we stay.
Getting somewhere.
Sounds good, sounds good. Dashamari, wait, what about the others? Tristan, Simon.
Trying to figure it out.
All right, good.
Getting there.
Love the sound of that. Very nice. I mean, I'm very encouraged.
Finish, sir.
Very nice. The rest of you, how far are we?
So unfinished, I need like just 2 minutes.
All right, granted. Check over for me, please, Astonil. The rest of you start working up, please. 2 more minutes, 2 more minutes.
Finish now, sir.
Simon, where are you? Hello.
What was that, sir?
I was calling on Simon, but Simon not answering me. Let's go. What, by the way, is it, what's the value of A?
I got
Minus
minus
one.
1,
B.
1.
3.
Okay, so one got 1, one got 3. All right, no problem. So minus 1 and 1. Shamari, I want you to check that. Three for me. Let me just go through the question. So we know the limit of a constant is a constant itself. The limit of a constant is a constant itself. So really and truly, to the left of 1, the limit is still 2. Because the limit of a constant, the 2 is a constant, is going to be the constant itself. That not change. The limit of a constant is the constant itself. So that won't change. So that is going to remain 2. Now, the other part says, to the right of 2, x is greater than or equals to 1. So to the right of 2, it must be, everything's supposed to be equals to 2. See it out here, so supposed to be equals to 2. So to the right of 2, I'm going to have the function ax plus b. So what I'm going to do is, anywhere in the function I see x, I'm going to substitute -1. So this is going to be a to the times -1 plus b, which is minus a plus b. That must be equals to 2. That must be equals to 2. Why, sir? Because I am trying to make the function continuous over the interval. Well, this one never tell you, or on the entire real line. You see the entire real line, it says function is continuous on the entire real line. See the entire real line here, negative infinity to positive infinity. That's what the entire real line is. From negative to positive. Negative oye oye to positive oye oye. So this is the entire real line. So I want you to get that. I want you to understand that. All right? So I'm finished with that. So I'm going to now look at when x equals 3. To the left of, let us look at to the right of 3 first. To the right of 3, it's a constant again. The limit of a constant is a constant itself. So that is still going to be equal to -2. See here? To the right of 3, the limit as x tends to 3 superscript to the right of 3 of -2. The mere fact that I don't have a variable to substitute that 3 in, I am just going to write back 2. The limit of a constant is a constant itself. So I have back my -2. Now I'm going to go back now and look at the left of -3. How you know it's the left, sir? Because this is x is less than 3. X is less than 3. So I'm going to use ax plus b. Now, anywhere in the function you see x, you're substituting 3. Anywhere in the function x, you're substituting 3. And it must be equal to this -2. So see it here, I'm substituting 3. 3 times a is 3a. See it right here, so plus a b equals -2. and then I'm solving simultaneously. Look at my simultaneous solution. And I'm using the elimination method. And what I'm doing right there is to eliminate my A's first. Then, so you have to eliminate the A's first? No, that's my choice. My choice is to go ahead and eliminate the A's first. Now, in eliminating my A's, look at what I'm going to have. I'm going to end up with rewriting my two equations, this and that. And what I'm going to do, I'm eliminating my A's first. So I'm going to multiply equation 1 by 3. Why, sir? Because I decided to eliminate my A's first. To eliminate my A's, I must have the same coefficients. I must have the same coefficients in order to eliminate it. So I'm going to multiply equation 1 by 3. So I'm going to end up with negative 3a plus 3b is equals to 6. So when I multiply equation 1 by 3, it's everything in equation 1. I'm going to be multiplying by 3. Every single thing. Not just piece. Everything. All right? And then, when I add both equations together, you see the signs are different again, Astonil? The signs are different, so I'm going to add both equations together. So when I add negative 3a to positive 3, I get 0. But watch this. Since I say that I'm adding, I can't just add the first one. I have to add every set of terms throughout the two equations. So if I add negative 3a to positive 3, I'm going to get 0. I must add 3b to positive b to give me 4b, to give me this 4b. Similarly, I'm adding 6 to negative 2 to give me 4. And because I want to find the value of b, I'm dividing both sides by the coefficient of this b here. So I'm dividing both sides by 4. And I'm going to get x to be equals to 1. All right. Shamari, you see your mistake yet?
Yes, sir, I found it.
Okay, good job. Always very important when you can find your own error. And then now, what I'm going to be doing, I'm going to substitute my value 1 into any of the two equations. This time I'm choosing equation 2. So anywhere in equation 2, I see b, I'm going to put 1. Equation 2, so I'm going to have 3a plus 1 equals negative 2. See here, 3a plus 1 is equal to negative 2. And I'm going to subtract 1 from both sides. So I'm going to have 3a is equal to negative 2 minus 1, which is negative 3. Divide both sides by positive 3. I'm going to get my a equals negative 1. How we feel?
Annoyed.
Annoyed?
Yeah,
Why?
not sure, but
Annoyed because you're now seeing that it's very easy.
sure, no bother with that.
You say you don't know, so I'm trying to find out, so I'm trying to help you. Yeah, man, it's really not difficult though. If you were to ask me, and don't say that, yeah, it's not difficult because you're the teacher. No, man. Remember, I was once a student too, you know. And this is not the difficult part. I will get to the difficult part and I will tell you. This is not the difficult part.
Sure. Today I
Yes,
was
madam.
on EducaSoft and I picked up a question, right?
Mm-hmm.
I worked the question and I got the response 0/9
Mm-hmm.
based on what the steps were supposed to be, right?
Mm-hmm.
But then I said, let me look at the solution before I submit my answer because I realized that there was nothing on the tab that presented a fraction to be the answer.
Mm-hmm.
And the answer was 0 instead of 0/9.
Yeah, because 0/9 is 0.
Huh?
0/9 is 0.
Interesting.
Mm-hmm. But 9/0 is undefined.
Right. But I didn't look at it that way. So I was gonna bring the question to class, but I left the paper at my desk.
Yeah, man, it's correct, man.
Okay.
So 0 over any number. Once you have a 0 in the numerator and a
Mhm.
number in the denominator, any other number in the denominator, your result is going to be 0.
Mm.
But if it flip it, the result is going to be
Mhm.
undefined because we can't
Mhm.
have a 0 existing in the denominator.
Got you.
Yeah, man. I love the look though, Arsenal. I mean, I can't hold you. For round 2, can't hold you. I like it. The attitude looks a little different too. That's why I answered, you know.
Mine is less occupied this semester.
All right. Love the sound of that. Love the sound of that. All right. So I wanted to do something else, but you know, it's now 7. I'm not going to complain, you know why? Because I have a class. I have 2 other sessions with you. I have 5 more sessions, 5 more hours with you for this week. But students, mine is a responsibility to encourage you to work and work hard. If you allow the something to pile up on you, you're not going to be able to recover. You're not going to be able to recover, and you are going to fail the course. And I'm being very frank and honest with you. If you allow it to run off, leave you, you're going to fail. Please keep abreast as to what is happening. Start working. For those of you who have not yet started, please start. Have a wonderful rest of the afternoon. Enjoy your other class.
Have a good evening, sir.
Yeah, as well, sir. Thanks.
No problem.
Thanks,